Now I'm going to look at the information in Module 7 of this online Math 137 class. Module 7 really deals with two different kinds of problems. First, we have what we call double angles. For instance, instead of theta, now we're going to try and determine the sine of 2 theta. 2 theta, whenever you multiply something by 2, that's called doubling something, right? So it's called double angle, or cosine 2 theta. And at the same time, we're going to look at how to calculate or compute or figure out half angles. So a half angle, of course, would be, or I guess maybe it's more common to write it sine of theta over 2, or of course a lot of students, sometimes this simple algebra stuff they stumble on. Initially I wrote 1/2 times theta, because when I said half angle, I thought of 1/2 times theta. Of course, this is the same. Matter of fact, it's amazing how students sometimes stumble over this kind of stuff. You have a fraction times a number, or in this case, a fraction times a variable. If you're going to combine these, you simply take the number times the numerator of the fraction. So 1/2 times 5 is the same as 5/2. All right, well, that was a quick detour. Now, when we're looking at double angles and half angles, we actually there are a bunch of formulas, a bunch of equations, just like we saw with the sum and difference of two angles. As a matter of fact, I brought with me, this is the actual formula sheet that you'll be given, you have access to for the midterm exam. You see this is labeled Math 137 Formula Sheet for midterm exams. You'll be given this formula sheet. If you look down here in the middle, we have a section labeled double angles. And actually I'm going to, so we can see this a little bit better. Now here, for angle, instead of, I normally use theta, they use u, but like use an angle. So there are actually some formulas. So for instance, sine of 2u equals 2 sine u cosine u. Now what's interesting is, look at cosine of 2u. There's actually 3 different formulas. It's almost like there's 3 possibilities. If you're asked to figure out cosine of a double angle, you can use whichever one of these you prefer. And then here is tangent of 2u. So for sine and tangent, there's just one formula, but for cosine, there's 3. And you have to choose which one you want to use. Usually I choose the one that I think looks the easiest. And then on down, we have the half angle formulas. Now, as we work through these, you're going to see one of the keys is, when you look at these half angle formulas, of course, they're all 3 of these are square roots. What's interesting, one thing is, if you look at the actual formulas, all three of them, the only thing they contain is the cosine. So once you know the cosine, you basically can figure out all the half angle formulas. But the thing I want you to really look at is what's here in front of the square roots, plus or minus. So that's going to become important because really, and this is a formula, there's really two possibilities. If I'm actually going to do a calculation to figure out the sine of my angle divided by 2 of this half angle, should I use the plus or should I use the minus, or maybe I use both? Maybe there's two answers. Well, let me tell you right now, there's actually not going to be two answers. There's just going to be one answer, but we have to figure out, should we use the plus or the minus? And we'll talk about that in a little bit. So what we're going to do is just work through some different kinds of problems you have in this section. So you'll see me, I'll be referring back to this formula sheet as we start working problems. So once again, for the exam, you will not have to memorize these formulas. You will be given these formulas if you need them on the exam. Now what I want to highlight, let's first look at some of the double angle formulas. Now I'm going to start using theta because I prefer to use theta as opposed to like u. So I'm going to write it. The sine of 2 theta is 2 sine theta times cosine theta. What I want you to notice is over here, inside the sine, inside the trig function, we have what we call our double angle, 2 theta. But over here, the actual formula, it's back to our usual sine theta, cosine theta. So even though we're trying to calculate a double angle, in order to calculate it, all we need to know are the normal trig functions, sine and cosine. And the same thing, normally when I have to determine the cosine of double angle, I usually use, since you have a choice of 3, I normally use this one because it always seems to be the easiest in terms of the math. So over here, once again, we're taking the cosine of 2 theta of a double angle, but over here, it equals 2 cosine squared theta minus 1. Now, just in case you get confused here, I could rewrite this. The way this is written, cosine squared theta, it means the same thing as this. In other words, you take the cosine of theta, and then you square it. Multiplied by 2, subtract 1. So the key is we have formulas where we can determine the trig functions of double angles, and it's based upon just normal trig functions. So from now on, when we do some problems where we're looking for double angles, we're going to use these formulas, and we basically have to figure out just the normal trig functions. And once you figure that out, then we're able to do these problems. Now the special thing about half angles, so plus or minus, we're going to discuss that as we start working some problems. So I have some problems. Basically, they're like the same kind of problems you're going to see in your homework. So let's try and work through this problem. Hopefully you can see it. Let me have you look at it, then I'm going to start working it out. So here they say, if the sine of theta is 5/6. So here they give us one trig function. They give us a sine of theta. And then they say, and oh, by the way, the angle theta is between 0 and pi over 2. Now hopefully if you remember our unit circle, 0 and pi over 2 is where? That's the first quadrant. So we know this angle theta is in the first quadrant. Then they say find the exact value of each of the following. And it's actually 4 parts. A is sine of 2 theta. B is cosine of 2 theta. So in A and B, we're trying to figure out the trig functions of some double angles. But then look at C and D. C is they want us to figure out the sine of theta over 2, and D is the cosine of theta over 2. So these are half angles. So basically in this one problem, we're sort of covering everything. We're doing some double angles and some half angles. And of course you see down here, when you do your homework, you enter the answers. Now the key is, notice this, we've talked about this before, find the exact value. So for these problems, you're not going to grab your calculator, you're not going to actually go on your calculator and use your sine or cosine key. Exact values means chances are there's a good chance some of these answers may have like radicals in them or square roots, because we're not going to use our calculators. So let me set this aside and I will just quickly write down the key information for this problem. So they gave us a trig function, sine of theta equals 5/6. Then they told us, so this angle theta, they say the angle is between 0 and pi over 2. So if you think about the unit circle, angle 0 is right here, pi over 2 is here, so our angle theta is in quadrant 1. That becomes important when we start plugging in trig functions, because the quadrant is going to determine whether the trig function is plus or minus. So we're back to that again. We have to know which quadrant the angle is in to know whether the value is going to be positive or negative. So the first one they ask us about, they want us to determine the value of sine of 2 theta. Well, up here, I know sine of theta. I don't know anything about sine of 2 theta. So what I'm going to do is I'm going to go use the formulas. So if we go back to our formula sheet, we've seen this before. 2u is 2 sine u cosine u. So for us, I'm going to say the sine of 2 theta is 2 sine theta times cosine of theta. So if I could determine what the value of sine of theta is and determine the value of cosine of theta, I plug them in here and I'm done. Well, they give us the sine of theta, 5/6. So in a sense, I can right now plug in 5/6. But somehow I need to know what the cosine of theta is. How can I determine the value of the cosine of theta? Well, this goes back to what we've done before. And the way I do these, if you're given a trig function, I'm going to take this trig function and create a right triangle. Right? Sine of theta, so cot TOA, so opposite over hypotenuse. Opposites like 5. Hypotenuse is 6. What do I do to get the third side of this triangle? Remember, I used the Pythagorean formula. In this case, I'm going to sort of do this quickly. I'm not going to do it the long way because we've done this many times before. You should be able to figure this out. Turns out I'm going to take the hypotenuse and I square it. Then I end up subtracting this one side squared. And when it's all said and done, this side of the triangle is square root of 11. So this is where exact values comes in now. I need to leave this as a square root. I'm not going to go grab my calculator and put it in a decimal. I leave it at square root of 11. Now if I look at this triangle and I say, okay, now that I've got this triangle, I should be able to determine what the cosine of theta is. So ka is adjacent over hypotenuse. Adjacent is square root of 11. Hypotenuse is 6. Now the key is, since my angle theta is in quadrant 1, I know both the sine and the cosine are both going to be positive numbers. Here they gave me the sine, which it better be positive, and it is. But the cosine, when I plug it in here, it's also going to be positive. So here, now we get back to doing some algebra, and I explained this beginning of this lecture. 2 times 5, 6 times square root of 11 over 6. The 2 gets multiplied by the other numerators. So 2 times 5 times square root of 11, 10 square root of 11, and then the denominators get multiplied. 6 times 6 is 36. Now 10 over 36, I can reduce that, right? Common factor of 2. So now we have calculated the sine of 2 theta. And I'm just checking, and that is the correct answer, to make sure I didn't make any mistakes. So that's just part A. Let me try and we need to maybe see this still for the rest of the problems. So now, part B said, what's the cosine of 2 theta? And I look at my formula sheet, which I have here, which you've seen already. And I'm going to go ahead and use the formula I used before. I'm going to use 2 cosine squared of theta minus 1. Once again, I'm going to write this again. Cosine squared of theta, the way it's written, means the same exact thing. It means you take the cosine of theta and you square the whole thing. So I know the cosine of theta, I found it up here, square root of 11 over 6. That whole thing is squared minus 1. Now this parenthesis squared, if you remember from algebra, this exponent gets applied both to the top and the bottom. So if you square the square root of 11, what happens when you square a square root? It just ends up being equal to what's inside the radical. And then 6 squared is 36. Now here we go again. 2, a number, whole number times a fraction. So it's really 2 times 11. So we have 22 over 36 minus 1. Now this actually once again reduces to 11 over 18 minus 1. I need to combine these. So here I have a fraction, and I've subtracted a number. In order to combine these, I have to get a common denominator. So 1, I rewrite as 18 over 18. So now if you remember how to subtract fractions, you write the common denominator, 11 minus 18. And then that is the cosine of 2 theta. All right, not too bad. Now let's look at, next is they said the sine theta over 2. All right. Now let's talk about this, because here we have, we've got our formula. Let me just write it down, and then let me talk about some things we have to figure out before we use the formula. Now look at the formula sheet for half angles. It's plus or minus square root of 1 minus cosine of theta over 2. Now the good thing is, I already know cosine of theta. Maybe I'll write it here. We've already figured it out from this earlier problem, right? Cosine of theta is square root of 11 over 6. So at some point, I'm going to plug that in here, and then I've got some sort of ugly math to do. But once again, the key question is, I've got this plus or minus in the front. I'm not going to have two answers. It's either going to be plus or it's going to be minus. And the question is, which one should it be? And here's how we determine that. We go back way at the beginning of the problem. When they told us our initial angle theta, they said it's greater than 0 and less than pi over 2. A lot of times we say theta is between 0 and pi over 2. So let me rewrite that here. And this is the way we're always going to have to work out these half angle problems. You write down the information about your original angle theta. But if I look here, at this point, I'm actually trying to figure out what is the sine of theta over 2. Here, I have information about theta. However, what I really want to know is, what about theta over 2? So what do? I can take and divide this theta by 2. I can do that, but I have to also divide the left side and the right side by 2. In other words, if I want to convert this from theta to theta over 2, I can do it, but I have to do the same thing to all three parts. So basically it means divide this by 2, and the pi over 2 gets divided by 2. So now I have this inequality for theta over 2, which is what I want, because that's what I'm trying to figure out. Now let's talk about this. This is sort of messy. First of all, this one's going to be easy, right? 0 divided by 2 is just 0. Because in effect, what this is going to tell me, where my theta over 2 angle is. Let's go and figure this out, and then we'll finish talking about that, and that should make sense to you. Now here's another tricky algebra issue that sometimes people struggle with. Let me actually just grab a separate sheet of paper and work it out. What happens there's a shortcut. Let me show you how it is, the actual proper way to do it, then I'll sort of show you the shortcut. This is called a complex fraction. You have a fraction over a number, although if you want to, we could convert the 2 in the bottom to a fraction. And if you remember, fraction over a fraction, this is just like division. I could write that fraction like this. Now, if you remember, the way we divide fractions is we write the first fraction, then we multiply by the reciprocal of the second fraction. So now, multiplying fractions, we multiply the numerators, multiply the denominators. When it's all said and done, this thing is power over 4. Now, normally, just for practice, if you ever have a complex fraction like this, you just simply write the top fraction multiplied by the reciprocal of the bottom fraction, right? We sort of skip this division step. We just go from here to here. And this would be like 10/12, which would be like 5/6. However, what we have initially, what if I have a fraction over a number? There's a shortcut when you have this situation. I did it the long way up here, but a shortcut is whenever you have a fraction over a number, it's almost like this number down here gets multiplied by this denominator. So really, the shortcut is it becomes 2 over 3 times 4. So let's go back to the original problem we had. So from now on, when I have something like this, the shortcut says I have a fraction, power over 2, divided by a number. I simply multiply my denominator by this number here. And you can see, of course, that's what I got up here. So it went the long way. So I'm going to start using this shortcut. So the key is, remember, from now on, you have a fraction divided by a number. You take the number and multiply it by the denominator, and then you're done. All right. Turns out we're going to be doing that a lot in these problems, so it's best if we understand how to do that now. So this basically is power over 4. So now, this power over 2 angle we're saying is going to be between 0 and power over 4. If we look at our unit circle, 0's here. Where's power over 4? Power over 4 is right here. What we're saying is, this half angle we're looking at is going to be somewhere in here. Obviously, in terms of quadrant, this little section here, where is it at? It's obvious to see that theta over 2 has to be in quadrant 1. Why is that important? Well, in quadrant 1, what is the sign? Positive or negative? The sign's positive. In quadrant 1, what's the cosine? Positive or negative? It's positive. Therefore, this tells me now, you know what? For this problem, since theta over 2 is in the first quadrant, I choose the positive here. For this problem, this is going to be the formula I use. So, to review, all these hoops we jumped through. We took the initial information they gave us about theta. We sort of converted this to theta over 2. And then we realized theta over 2, for our problem, was between 0 and pi over 4, which means I could have stopped right here and just said, well, that's obviously quadrant 1. So then I know, okay, in quadrant 1, both the sine and the cosine are positive, and then that tells me what the formula should be. So I'm going to do this one, and in a minute, we'll do the cosine of theta over 2, and when we do the cosine of theta over 2, it's also going to be positive. And that equation is going to be 1 plus cosine of theta over 2. So this right here helps me figure out whether it's plus or minus. So let's do the math now. So now we know that for sine of theta over 2, this is the formula. One minus cosine of theta is square root of 11 over 6. And this whole thing over 2. You know what? I'm going to have to jump down here and do some simplifying. This is pretty messy. So now we go back to some messy algebra, which you're going to have to remember how to do your algebra. So let me rewrite this to see what we need to do. To simplify this, first thing I need to do is this 1 minus square root of 11 over 6, I want to turn that into one fraction. Well, for that to occur, what has to happen? I have to have a common denominator. So this 1, I'm going to rewrite as 6 over 6. Now that I have a common denominator, so now 1 minus square root of 11 over 6, as one fraction, I can write it as 6 minus square root of 11 over 6. All that's over 2, and all that is under the square root. Very, very messy. Now, if you look, what do I have here? I have a fraction divided by a number. I just spent a lot of time a few minutes ago telling you what would be the shortcut to simplify this. Remember, you take the number times the denominator. So I can actually simplify this and say it's going to be 6 minus square root of 11. 2 times 6 is 12. Now, we're not quite done yet. This numerator in here, I'm done with the numerator. Nothing I can do to simplify it. However, if I look at this 12 here, 12 is like 4 times 3. Let me do it this in case some of you are confused. Whenever you have a fraction under a square root, you can actually break it up into two separate radicals. Square root of 12 simplifies 4 times 3. The 4 can come out as a 2, right? So I end up with square root of 12 is 2 times square root of 3. And then this is just in the top here. Now, the last step is I basically have 1 over 2, then I have a square root over a square root, I can now recombine these as the final step and write my answer as 1/2 6 minus square root of 11 . Wow, I was wrong. Sorry. 1/2 6 minus square root of 11 over 3. This looks pretty ugly, but that is actually the answer. So in the homework, you're going to be able to have to do this kind of math. That's why I've taken the time to show you this is a lot of pretty involved algebra. So this right here was sine of theta over 2. Now on the next page, we're going to have to figure out cosine of theta over 2. So once again, let's write down the key information. First of all, from way back at the beginning, we figured out cosine of theta is square root of 11 over 6. And we know for the half angle, we figured out it's going to be a positive. So it's positive the square root of 1 plus cosine of theta over 2. So I'm going to plug this in for cosine of theta. 1 plus square root of 11 over 6. Now I'm going to do some sort of shortcuts here. It's the same kind of problem we just did. I want to combine these into one fraction. So I'm going to make the 1 a 6 over 6. So hopefully you all see that I end up with this whole thing under the square root. And now I have a fraction over a number. We've talked about that. So I multiply the 2 times the 6. And this is just like the one we did earlier, where now I have, there's nothing I can do with this numerator, but the square root of 12 simplifies into 2 square root of 3. So when it's all said and done, it looks very similar to the sine, except you notice the cosine, it's 6 plus square root of 11, and the sine, 6 minus square root of 11. Wow. All right, that was one problem. That was this one problem that we worked out. They gave us a trig function, they told us where the angle was, and they asked for these 4 new trig functions. So pretty involved. As a matter of fact, I might do one more quick one, and I'm going to go through it pretty quick. I'll probably not do every single step, but now that you've seen in detail how to do one, maybe do one more quick one that's got a couple twists to it, so that when you see these on the homework, you'll know what to do. So this one looks pretty similar to one we just did, but there's a couple twists to it, so let me just step through. I won't probably do all of these, but I'll just do all of the setup. Here, they give us a trig function, tangent of theta is 8/7. Once again, they tell us where theta is. In this case, it's between pi and 3 pi over 2. And then they ask for the same 4 things. I'm not going to do all 4 of these. I'll probably just do one of each of these. But I want to go through setting it up because there's a few twists here that make this problem different than the one we just did. Not really different, but just a little with the sines and other things. So let me quickly write this one down. I'll go through this pretty quick. There's a trig function, and then they say that initial angle theta is between pi and 3 pi over 2. And then they ask us to find the 4 things. I'm just going to find 2 of them. I'm going to find the sine of 2 theta, and then I'll do the sine of theta over 2. So sine of 2 theta, the formula is 2 sine theta cosine theta. I know tangent of theta. What I really need is sine theta cosine theta. Now, let's think about this for a minute. If the angle theta is between pi and 3 pi over 2, where is that at? If you think about our unit circle, pi is here, 3 pi over 2 here is here, so theta must be in here. I can sort of mark up here. I know that that angle is in quadrant 3. That's important because eventually I'm going to have to go figure out what the sine of theta is and what the cosine of theta is. And what do you know about these? The sine of theta and cosine theta? I know they're both going to be negative because sine and cosine are both negative in quadrant 3. So when I plug in my numbers in here, I've got to make sure both those numbers are negative. Now, how do I go about figuring out what the sine of theta and the cosine of theta is? Well, I take my trig function, in this case, tangent, so-called TOA, right? TOA, tangent, is opposite over adjacent. So I'm going to go create a right triangle based off of that trig function. Opposite is 8, adjacent 7. Now to get my hypotenuse, once again, Pythagorean formula, you take this leg and you square it, which is 64. You take this one and you square it, which is 49. If you can believe it, the hypotenuse is the square root of 113. That does not simplify. Once again, since they're asking for exact answers, I have to leave this as square root of 113. So now, let's just figure out what sine and cosine are. So for this theta here, in terms of the number, sine is opposite over hypotenuse, right? 8 over square root of 113. But now, because I know I'm in quadrant 3, I have to make it negative. The cosine is adjacent over hypotenuse. Adjacent, 7, hypotenuse, square root of 113. Now, in quadrant 3, what's the cosine? Positive or negative? It's also negative. So now I have my sine and cosine. I can plug them in here and get my answer. 2 times the sine of theta is negative 8, square root of 113, times the cosine of theta is negative 7, now we just have to do some math. It's going to be 2 times negative 8 times negative 7. First of all, 2 negatives make a positive. Actually, 8 times 7 is 56 times 2. Now in the denominator, I have square root of 113 times square root of 113. This is like square root of 113 squared. What do you get? And that is, in fact, the answer. I'm not going to do the cosine of 2 theta because it's just another formula, and you plug the appropriate trig functions in, and you're good to go. But now, let's go ahead and see what is up with the half angle. So once again, the formula for the sine of theta over 2, I'm getting my formula sheet because I don't want to, I don't have these memorized. Once again, plus or minus 1 minus cosine of theta over 2. The key is, let's go figure out, when I finally do this calculation, is it going to be a positive or negative answer? So remember what you do? You go back and get your original inequality for theta, and I'm going to write it right here. So originally theta is between pi and 3 pi over 2. I want to convert this inequality, instead of theta, I want it to be theta over 2. So I'm going to divide everything by 2. Now these two are pretty straightforward, right? Theta over 2, pi over 2, theta over 2. Here we go again. All right, but we know how to do this now, right? A fraction over a number. What's the shortcut? You take the number times this denominator. So this ends up being... So now we're saying this half angle, theta over 2, is between pi over 2 and 3 pi over 4. Let's figure out where that is on our unit circle. Pi over 2 is right here. 3 pi over 4 is right here. So you know what? We've discovered this half angle is somewhere in here. What quadrant is that going to be? It's going to be quadrant 2. And what do we know about quadrant 2? In quadrant 2, the sine is positive, the cosine is negative. Now for my original problem, if I look at this triangle, So, we now determine, since we know we're looking for the sine of theta over 2, we know since we're in quadrant 2, it's going to be positive. So right now, I can eliminate it and say, this is my formula. Now, I'm not going to do the cosine, but if I did the cosine, since I'm in quadrant 2, the cosine is negative, so I'm going to use the negative. And this would be the formula I would use if I was going to calculate the cosine of theta over 2. So by being in quadrant 2, I know the sine of the half angle is a positive, and the cosine of the half angle is negative. And that's based upon now figuring out that my half angle is in quadrant 2. So just for fun, let's go and do the sine of theta over 2. Once again, it could be pretty messy. So it's going to be the square root of 1 minus cosine of theta, which I, once again, get back up here, 7 over square root of 113. Be careful though. See, I almost messed up. The cosine, I wrote it down right here. This cosine is also negative. Let's retrace it. Back to theta, tangent theta, 8/7. I created my triangle. I figured out for theta, I'm in the third quadrant. For this theta, I figured out sine and cosine, they were both negative. This is the cosine I'm now going to plug in down here. This cosine is actually negative. So I have 1 minus cosine theta. Cosine theta is negative 7 over square root of 13. And this is why I did this problem. It gets a little crazy. So once again, just to make sure everybody sees it, it's like I have two things going on. I have to figure out the plus or minus outside the radical. And I do all of this to figure that out. And I've determined for sine of theta over 2, it's positive. Now when I go in and actually start plugging in numbers into the formula, when I needed to plug in cosine of theta, that cosine of theta I derived way back from all this work up here. And when I did all this work up here, I realized cosine of theta is negative square root of 7, or negative 7 over square root of 113. So that's why I plugged that in here. So now, if I do the math, really this, what happens when you subtract a negative? Now, I need to combine 1 and this fraction. I'm going to make this one fraction. So this 1 becomes really square root of 113. I should probably show you that. I need to combine. I need to make this one fraction. My denominator's got to be this. So my 1 so when it's all said and done, this is a fraction I have. So this whole thing becomes square root of 113 plus 7 over square root of 113 all over 2. So now I have a fraction over a number. So what do? I multiply this number times the denominator. So it really becomes square root of 113 plus 7 over 2 square root of 113. And if you can believe it, that should be the correct answer. Except, you know what, when I look at it, they don't like this. If you can believe it, there's an extra step. This is like the problem that never ends. So we're sitting here. I need to show you this because in the homework, it's not going to count as correct unless you do one more step. They don't like this square root here in this bottom of this fraction. So you remember the way you get rid of a square root down here is you multiply top and the bottom. By the square root. So the bottom becomes square root of 113 times square root of 113, which is just 113 times 2. Now if I distribute this times this is just 113, and then 7 times this, and then this is actually the answer they want to see. I know, pretty unbelievable how messy it is, but it is what it is. All right, let me stop now, and there's a few more problems I'm going to do, and I'll just start with another video.